Okay, so we're going to start with trigonometry. Trigonometry is very used. You're going to be looking in an engineer. You're going to be an engineer later on, or people that boats as well. People that going to be in the Navy. They use angles. They use this thing called trigonometry. But first of all, let me go over what trigonometry. We're going to learn how to do ratios. Ratios, a fancy word for the fraction. So we're gonna use right triangle. So let me just let's say there's a right triangle. We know that the biggest side of that triangle, it's called hypotenuse. So let me just go here, hypotenuse. Now the other two sides, they're going to be called opposite or adjacent. Opposite means far away. Adjacent means close to. So I'm going to mark one of the other angles, one of the corners, not the 90-degree angle, one of the other corners. I'm going to mark it down. I'm going to use for today, let me use this Greek letter called theta, like a zero with a little line that basically represents measurements of angles. So I'm going to put the theta at one of my corners, and I'm going to put it there. So this side, I'm going to call this opposite. Opposite means it's far away, right? Far away from my theta, this side is opposite. Close to my theta, we're going to use the word adjacent. Adjacent means close to. So the sides are going to be called hypotenuse, opposite, and adjacent. Now, there's going to be 6 ratios we're going to learn. Okay, 6 ratios. One of them is going to be called cosine. The other one is, let's call this sine, and the other one is going to be called tangent. Now we're going to abbreviate each of these just using the first 3 letters, okay? So COS, that means cosine, SIN, that means sine, and TAN, we're going to call that tangent. Like so those 3, I'm going to abbreviate those just using the first 3 letters. Now cosine, like I said, is going to be a fraction. It's going to be adjacent. It's going to abbreviate these in the first 3 letters over hypotenuse. So cosine is adjacent over hypotenuse. Sine is going to be opposite over hypotenuse. And tangent is going to be opposite over adjacent. So matter of fact, there's going to be one way you guys can remember this. Let me use the acronym. I'm going to write it here at the bottom. So, ka and toa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So like I said, we're going to go into this ratios. Like I said, these are fractions. Now, the other 3, because I said we're going to be looking at 6 names. The other 3, one of them is going to be called cosecant. I'm going to write it here at the bottom on the right. One of it is going to be called cosecant. And we're going to also use secant and cotangent. Now, cotangent, we're going to be able to abbreviate that using the first 3 letters. Secant, we're also going to abbreviate that using the first 3 letters. Now, cosecant, we're not going to. Because the first 3 letters, COS, we don't want to get confused with cosine. So we're going to abbreviate that as CSC, right? Cosecant. Okay, now look at cotangent, COT. That kind of looks like tangent backwards, right? So I'm going to say COT, so right, for cotangent. So matter of fact, let me call it cotangent of theta. So let me call this, all of this of theta. Cotangent, it looks like tangent backwards, right? It kind of looks like TAN backwards. Now, cotangent is going to be adjacent over opposite. It's the reciprocal, right? When you flip tangent. Look at secant. Let me write secant over here. I'm going to write it up on the very top. That looks like cosine backwards, right? And pretty much is going to be the reciprocal of cosine. So it's going to be hypotenuse over adjacent. And the last one, cosecant of theta. So cosecant is the reciprocal of sine. So it's going to be hypotenuse over opposite. Make sure you guys write somewhere this chart, okay? On the notes, I'm going to say according to our chart, and this is what I mean, according to this table. Okay, so let's take a look at questions 1 through 6. Find the value of the trigonometric function indicated. Okay, so cosine of theta. Let me label my sides. The biggest side of all, the one away from the 90 degrees, that's the hypotenuse. I'm going to label this hypotenuse. You guys see theta is at this corner. So 12 is the opposite, and 12 radical 3 is the adjacent. Remember, opposite means far away, adjacent means close to. Cosecant. I know cosecant. Let me, in case you have not written your functions, let me go here. Feel free to pause this. Okay. Now, cosecant is going to be hypotenuse over opposite. All right, cosecant is hypotenuse over opposite. So I'm just going to write 24 over 12. Simplify your fraction if possible. 24 divided by 12 is 2. So my function is going to be 2. If we have radicals at the bottom, we got to get rid of those. But in this case, we don't. So remember, cosecant is hypotenuse over opposite, 24 over 12, which is 2. Simplify your fraction if possible. The hard part will be identifying the 3 sides. Which one's hypotenuse, opposite, and adjacent? Hypotenuse is easy, right? It's the big side right here. This is hypotenuse, the biggest side. I see where theta is, right? Is this corner. So this 6 is my opposite, and this 6 is my adjacent. Cotangent, I know is adjacent over opposite. A over O. So it's going to be 6 over 6. 6 divided by 6 is just 1. All right, let's take a look at question number 3. Let me label the sides. This is the hypotenuse, so that's easy. I see theta. It's right here. Right, opposite is far away. Adjacent is close to. Now, cosine is going to be adjacent over hypotenuse. So I'm going to go 23 over 23 radical 2. Good thing is that 23's cancel out, right? That they're gone. The 23's cancel out. Now, my problem is I cannot have radicals at the bottom. So what I'm going to do, let me multiply top and bottom by radical 2. Because I know at the bottom, radical 2 times radical 2 is 2. Except don't want radicals at the bottom. On the top, I just have radical 2. So my answer is radical 2 over 2. Writing it, it's easy, right? Radical 2 over 2. Now typing it, I'm going to write radical 2 over 2. Notice I'm using the backslash for a fraction. Anything before the backslash is what goes on the top. Everything after the backslash is what's at the bottom. Okay, so let's take a look at here. Let me label my sides. This is the hypotenuse. I see where theta is, so this is my opposite, this is my adjacent. Sine, according to our chart, sine is opposite over hypotenuse. So it's going to be 5 over 5 radical 2. My 5's cancel out. cannot have radical 2 at the bottom. So let me multiply top and bottom by radical 2. So the bottom is 2. On the top, I have radical 2. So my answer is radical 2 over 2. So I type this as radical 2 over 2. Okay, let's take a look at a couple more examples. Tangent. According to our table, well, actually, let me label my sides first, right? So this is my hypotenuse, this is my opposite, and this is the adjacent. I see theta here. Tangent is opposite over adjacent. So it's 9 over 6. Simplify your fraction if possible. I'm going to divide each by 3. So my fraction would be 3 over 2. My answer is 3 over 2. Simplify your fractions. Looking at number 6. The biggest side is the hypotenuse. I see where theta is. So this is the opposite. This is the adjacent. Now secant. Secant is hypotenuse over adjacent. So 20 over 12. Let me divide each by 4. 20 divided by 4, 12 divided by 4. So my answer is going to be 5 over 3. Simplify your fractions. 20 over 12 will be considered wrong. 5 over 3 is considered correct. Don't forget to simplify your fractions.